Welcome back to day 9 of digital learning. Today we're going over Unit 6, Lesson 2.1. But before we go working on that, I want us to go over no sand in the sandwiches, the worksheet from yesterday that you had to do. So please take that out so we can go over it. This is the worksheet from yesterday, no sand in the sandwiches. So we're going to be going over that now. When Mrs. Baxter takes her 3 children to the beach, she always makes sandwiches to bring. She cuts each sandwich into 4 equal pieces. She puts them in a large container. At the beach, everyone can take a piece when one is wanted and not worry about sand. Mrs. Baxter is only going to eat 1 whole sandwich at the beach, but her children will eat 2 whole sandwiches each. How many sandwich pieces will Mrs. Baxter have to put in the container? Show all your math thinking. So I'm going to first start taking notes. I'm going to reread my problem, take notes. When Mrs. Baxter takes her 3 children to the beach, she always makes sandwiches to bring. So Mrs. Baxter and 3 children. So I'm going to write Mrs. B and 3 children. She cuts each keyword sandwich into 4 equal pieces. Each sandwich into 4 equal pieces. I'm going to write S because I'm going to start writing sandwich as S. Since it's just a longer word, I'm going to make it shorter. Each sandwich to 4 equal pieces. She puts them in a large container. At the beach, everyone can take a piece when one is wanted and not worry about sand. Mrs. Baxter is only going to eat 1 whole sandwich. Mrs. Baxter is only going to eat 1 whole sandwich at the beach, but her children will eat 2 whole sandwiches each. So I'm going to write Mrs. B eats 1 S. Remember, S stands for sandwich. And children eat 2 sandwiches each. I know each child is going to eat 2 sandwiches. The question is, how many sandwich pieces will Mrs. Baxter have to put in the container? So I'm trying to figure out how many sandwich pieces. And how I'm going to figure this out is with a table. So I can make a table by writing the person, number of sandwiches, and then number of pieces. That way I can know how many pieces each person will have of sandwiches. So person 1, I'm going to write Mrs. B, and she had 1 sandwich. So if I drew a picture of 1 sandwich and made it into 4 equal parts, that means Mrs. B is going to have 4 pieces of sandwich. And then I know that there's going to be 3 children. 3 children. So I'm going to do child 1, and they had 2 sandwiches. So I could do the same thing with drawing a picture of 2 sandwiches and breaking it into 4 parts each. 1, 2, 3, 4, 5, 6, 7, 8. So that child had 8 pieces. Child 2 also had 2 sandwiches. And now I see kind of an equation that I can do. So I see that if I have 2 sandwiches and they're cut into 4 pieces, then I'm going to have 8 pieces. Do the same thing with child 3. If I had 2 sandwiches that were cut into 4 pieces, I would have 8 pieces of sandwich. So now I have how many pieces each person gets. But it's important for me to understand that I'm not done yet, because my question isn't just how many each person gets, it's how many sandwich pieces will Mrs. Baxter have to put in the container. So I need to know how many all of these pieces are. So I see that I have 1, 2, 3 pieces that are 8. So instead of doing 8 plus 8 plus 8, I can do 8 times 3, and I can skip count by 8, 9, 10, 11, 12, 13, 14, 15, 16. I counted up 8, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 8 times 3 is 24. So now I have how many pieces each child, or how many pieces all the children had. But I still have how many pieces Mrs. Baxter had. So I'd have to do 24 plus 4 equals 28 pieces of sandwich. So now I can answer my question by writing a complete sentence. So I would write, Mrs. Baxter had to put 28 pieces of sandwich in the container. So our lesson today is going to be a little bit different because you don't have the materials at home that we would have in our classroom. But before we start, I just want us to go over our posters and our resources. So during day 7, I asked us to make a rule for what it means when a numerator and denominator are the same. And so our rule is when a numerator and denominator are the same, it equals 1. Just like 8 over 8, 6 over 6, that equals a whole, or 1. I also want us to go up here, and we talked about yesterday mixed numbers, and that means when a whole number and a fraction are together or mixed, that's a mixed number. So 3 1/2 would be a mixed number because it has 3, which is a whole number, and a half, which is a fraction. And I know the quality isn't great, so I'm also going to be uploading those into our materials as our fraction posters. What we're doing today is playing a fraction cookie game. And since you don't have all the materials at home, we're just going to be doing it as a class. So the directions are to roll the cube. So we have 2 fractions that we're able to roll. And we want to get the least amount of shapes to fill up our hexagon. So remember that a trapezoid is equal to 1/2 because it takes 2 trapezoids to fill up my hexagon. 1 triangle is 1/6 because it takes 6 triangles to fill up my hexagon, and a rhombus is 1/3 because it takes 3 rhombuses to fill up my hexagon. So I'm going to roll twice, and I have 1/2 plus 2/3. What I need to do here is I need to use the least amount of shapes that I can. So I have 1/2 and 2/3. So I'm going to add them up and see how many that I get, or what is my total. So if I did 1/2 plus 2/3, so I know that I can do 1 trapezoid, and I can do 1 rhombus. So right now I have 1/2 and 1/3. How can I put my last 1/3 in here? So I know that I can put one triangle here and another triangle over here. And that's okay for me to do because I remember that 2 triangles, so 2/6, are equal to 1/3. So remember our equivalent fractions, that 1/3 is equal to 2/6. And I just proved that by being able to use 2 triangles instead of 1 rhombus. So now I'm going to figure out my answer for what 1/2 plus 2/3 equals. And I see that 1/2 plus 2/3 equals 1 whole and 1/6. So I'd write that as a mixed number as 1 and 1/6. Because I have 1 whole filled up, I was able to separate my 1/3 because I know it's equal to 2/6. So I put 2 triangles and I have 1 and 1/6 filled. So now I'm going to do another round. But I already have 1/6 of my hexagon filled and I can't move on to my next hexagon until this one is totally filled. So let's see what I roll. So we already did that one. I'm going to do. I'm going to switch it up. So now I have 1/6 plus 2/3. I'm going to write my equation here. 1/6 plus 2/3. I want you to pause me now and think about how you can solve 1/6 plus 2/3. What shapes would you be using to add these two fractions together? So I can use 1 triangle because that's 1/6. And then I can do 2/3. So that would be 2 rhombuses because each rhombus is 1/3. And that fills up my hexagon perfectly. So that kind of shows me that 1/6 plus 1/6 plus 1/3 plus 1/3 is equal to what? It's equal to 1 whole. Because I know that 2/6 is also equal to 1/3. What I want you to do now is pause me and think about how can I get the least amount of shapes in this? What can I switch out to get a different shape, to have less shapes or fractions inside? You said that I can, instead of having 2 triangles, instead of having 2 triangles, I could switch it out for 1 rhombus. I can do that. So now I would have 3/3, which is equal to 1 whole. So that's showing me 3/3 is equal to 1. Because remember, if my numerator is the same as my denominator, that is equal to 1 whole. Let's look at my first hexagon. What shape can I swap out now to have the least amount of shapes? You said that I can get rid of my triangle, or 1/6, and my rhombus, which is 1/3, and replace it with a trapezoid. The trapezoid, you'd be right. So what I see here, that 1/6 plus 1/3 is equal to one trapezoid, and my trapezoid is equal to 1/2. The reason that I know that this is equal to 1/2 is I could also think of different equivalent fractions. So I know that 1/3 is equal to 2/6. So if I did 1/6 plus 1, that's equal, or 1/6 plus 2/6, that's equal to 3/6, which is also equivalent to 1/2. They're the same amount, which I just saw by being able to swap out my triangle and my rhombus. What shape can I swap out now to get the least amount of shapes in my hexagon? I could have also swapped out both of my trapezoids, so 1/2 and 1/2, with just one hexagon, and my one hexagon is equal to 1 whole. So what we just did is that we were able to use pattern blocks to show how equivalent fractions are the same. What I would like you to do now is do the equivalent fraction worksheets that are also in this assignment. Please take your time and show your work while you're doing this to make sure that you're getting the correct answers. Don't fly through it, and actually be showing your work either using a number line, a fraction bar, or the pattern blocks, or drawing a picture to help you find your correct answer. Now that you made it to the end of the video, please enjoy my dog.